Have you ever thought about that gap between just being a good computer user and being a system administrator?
Oh, it's a huge gap.
I mean, we're talking about the shift from asking, why is the network slow, to actually being the person who designed the whole multi-zone network.
And configure the DHCP server and secure the VPN connection.
Yeah,
Yeah,
exactly.
that transition it's massive. It's probably the most critical jump in an IT career. You're moving from just, interacting with the surface, the apps, to really mastering the infrastructure underneath.
You have to know what's happening from the second you hit the power button.
Right. How data moves, and more importantly, how to stop it from failing or, getting compromised.
Okay, so let's unpack this. We've got a really interesting source today. It's the syllabus for a college-level system administration course,
Mhm.
CS123 from Skidmore College for spring 2026.
And this isn't just some abstract list. It's a very detailed, very hands-on map for what core IT competence looks like right now, especially in a security-first world.
So our mission for you listening is to really pull out the three core pillars of modern sysadmin knowledge from this. We're talking shell scripting, server operations, and of course, network security.
And we're going to isolate the specific hands-on tools and concepts that really form the bedrock of, true professional competence.
Great. Let's jump right in. The syllabus states the core goal is twofold. First, it's about providing enough detail and hands-on work to handle routine server management.
Yeah, the daily stuff. Catching, checking logs, updating.
The things that if you do them right, no one even knows you were there.
Exactly. But the second part, and I think this is the more critical focus, is woven through everything. It's about explicitly detailing security risks and the mitigations for every single thing you configure.
So you're saying system administration is security configuration.
Fundamentally, every time you edit a config file, you're making a security decision.
So what does this skill set actually look like? The first objective is clear. We become adept at using the command shell on a Linux system.
And not just using it. The key word is proficiency in shell scripting for the ultimate administrative goal.
Automating repetitive processes.
Always. If you do something more than twice, you write a script for it, period.
And this requires a specific toolbox. We're talking about learning utilities like Nmap for network mapping.
So you know what's actually on your network.
And Flesk, the file system check utility. That's for when things go wrong, right?
When a system crashes, yeah.
Yeah.
It maintains integrity. But there was another objective I found really insightful. It wasn't a tool at all.
What was it?
It was a meta skill. Just being able to find and understand system documentation. No one knows every single command flag, but a pro knows how to find the man pages and interpret them fast. That's a job saver.
That's a fantastic point. Okay, so speaking of hands-on, the technical environment they use sounds pretty serious.
It is. They're working with live, persistent virtual machines, not some disposable sandbox. They're using KVM, kernel virtual machines.
And that's important because it's an enterprise standard.
It is. It's open source, it's widely used, and the operating system is a current version of Fedora Linux.
Why Fedora specifically?
Well, Fedora is often the proving ground for technologies that end up in Red Hat Enterprise Linux. So it keeps them on the cutting edge.
And access is all via SSH?
Solely via SSH. And here's the kicker. They get full administrative control, root access. If they break it, they fix it. If they leave a security hole open, well, that's their problem.
Wow. Okay, that's real responsibility. This brings us to the next section. Command line mastery and automation. This is where the power really lies, right? Avoiding tedious work.
Absolutely. The course starts with the non-negotiable building blocks. Files, directories, paths, and then it dives into inodes.
Okay, let's pause on that. Inodes.
Yeah.
What are they in simple terms?
Think of an inode as the ID badge for every single piece of data. It's not the file name, it's the metadata. Who owns it, what are the permissions, and where the actual data blocks are on the disk.
So Linux doesn't actually see file names, it sees inode numbers.
Exactly. If you lose the inode, the file is gone, even if the data is still physically there.
That makes so much sense. Okay, so after that, they learn the mechanics of pipes and redirects.
Which is the essential plumbing of the shell. It's what lets you take the output of one command and just feed it directly into the next one. It's how you build those powerful automation chains.
And the tools they learn are the classics. You have your basics like else, cd, cat. Then you get into process management with PC stop.
And nice for adjusting priority. And of course, the remote tools that CS for login and CP for secure file transfer. Those become your eyes and hands on a remote server.
But for the actual scripting, the syllabus lists a specific quartet of tools for like processing log files. You have grep, WC, SED, and awk. Why those four?
Because they create a data processing pipeline. Think of it this way. grep finds the needle in the haystack, the specific line you need. Find needle, then modifies that needle, maybe deletes a column or swaps two words. And awk is the master report generator. It takes all that structured data and summarizes it or reformats it into something human-readable. You can process gigabytes of logs without ever opening a text editor.
That's incredibly powerful. And all this builds to the final project, a sophisticated bash script to automate common server management tasks.
And the standards are really high. The script has to check its parameters, verify that commands actually work, and, alert you if something goes wrong.
It has to be broken into logical functions, be well documented, and this is key, it has to check return codes.
Yes.
What are return codes and why is that so important?
Every command in Linux, when it finishes, it sends back a small number. A 0 usually means success, and a non-zero number means some kind of failure.
So an amateur script just assumes it worked?
Right. It just moves on to the next line. A professional script checks that code immediately. It asks, did that actually work? If not, it stops, it logs the error, and prevents a cascade of failures. It's about building trust in your automation.
Right, building trust. Okay, let's move on to section 3. Server configuration and hands-on security. This is where those scripting skills get applied to the OS itself.
And they cover the whole life cycle. It starts right at the beginning. Boot configuration with grub and kernel images. Then you move to the file system formatting, encryption.
Which is not optional anymore.
Not at all. And file system integrity with vsouq, proper mounting procedures, all of that.
What about access control? That's got to be huge.
Oh, yeah. They focus heavily on moving beyond passwords to SSH keys. That alone just wipes out a whole class of brute force attacks. They learn user administration, the difference between su and the proper use of sudo.
And then the routine stuff. Patching with yum or DNF, process control with kill, and scheduling jobs with cron.
Right. And the curriculum is very specific about the configuration files they need to master. They call out the sacred text.
The infamous duo, et cetera, et cetera, et cetera.
Exactly. And etc. shadow is the crown jewel for an attacker. It doesn't have the password, but it has the encrypted hash of the password. If an attacker can read that file, it's pretty much game over. They can crack those hashes offline.
So understanding the security around that one file is just non-negotiable.
Absolutely. They also cover etc. for scheduling and, of course, the entire log directory for forensics.
And I love this detail. They have a fun incentive to make this all stick. It's called the server deployment night.
Yes, a whole evening dedicated to this high-stakes collaborative project. The goal is to set up a server that acts as a firewall and a router for a multi-zone network. It's where the rubber meets the road.
Wait, hold on. It says here the evening includes crucial design resources. Specifically, it says the design process is fueled by pizza and soda.
Well, of course. Every sysadmin knows the best firewall rules are written around 11 p.m. with a slice of cold pepperoni. It's about simulating real operational pressure, with the necessary morale support.
That's amazing. And it brings us perfectly to section 4, networking and infrastructure design. Because you can be the best server admin, but if you don't get the networking right, you just have a very secure island.
This section grounds everything. They dive into the conceptual models, the OSI and IP models, packet structure, TCP versus UDP, address classes, well-known ports, all of it.
The absolute fundamentals.
Right, because Ethernet and IP, that's the foundation of basically every corporate network out there.
So they cover addressing, McCossing, and IP addresses and how to organize them with subnets and masks. Then they get into the services that make it all work, like ARP, DHCP, and of course DNS.
And they need the diagnostic tools for that.
Yeah.
So dig and look up for DNS, and then the classics, ping and traceroute.
But the real application here is security. Configuring firewalls with firewall CMD, managing NAT, using SSH tunneling.
And understanding VPNs. Then they get into the physical architecture, switches, routers, firewalls, and then the critical design strategies like VLANs and setting up DMZs.
Okay, a DMZ. A lot of people have heard that term. In simple terms, what is it for?
The DMZ, or a demilitarized zone, is essentially a buffer network. It's like a lobby that sits between the public internet and your private internal network.
So your web server would live there.
Exactly. Your web server, your email server, anything that has to be public-facing, it sits in the DMZ. So if that server gets hacked, the attacker is still stuck in the lobby. They haven't breached the main fortress of your internal corporate network.
That security mindset is just woven through every single layer here. Okay, let's wrap up with section 5, which is about the system administrator's mindset Information literacy and ethics.
And this is so important. The course reinforces that skills are useless if you can't troubleshoot. Students are expected to find and evaluate sources critically.
They're pointed to the good stuff, right?
Yeah.
Man pages, vendor sites.
And respected bodies like NIST, ISC2, the SANS Institute, they're taught to weigh credibility, even when they're on a crowdsourced site like Stack Exchange.
And the instructor uses a collaborative reading tool called Perusal. What's that about?
It's fascinating. It's designed to fight low retention from just, passive reading. It lets students highlight, annotate, and see each other's notes right on the text. It turns reading into a conversation.
So it encourages active learning.
And it's part of their grade. Participation in labs, on Perusal, on discussion boards. It's about being engaged.
Okay, now we have to talk about the academic integrity section. It contains some really hard rules that speak directly to the modern challenges.
It's strict. No copying code, not even parts of it. No making trivial changes to someone else's work. That's standard stuff.
But there's one rule in here that just jumped out at me.
I know which one you mean.
It says, and I'm quoting, "The use of any online source, including AI-generated code, is improper collaboration and an academic integrity violation."
That is a phenomenal statement, isn't it?
It really is. In a field that is all about efficiency and automation, they're explicitly banning generative AI, even for fixing simple syntax.
Exactly. And they give the clearest symptom of a violation. It's an inability to explain the thought process behind your own code. The professional sysadmin has to own every single line they write or configure. You can't delegate understanding.
So let's synthesize this. We've got the three pillars: mastering the shell for automation, building a secure Linux server, and designing a multi-zone network. The end goal is to automate routine tasks and deploy a fully secure, functional network from scratch.
But when you put it all together, you see this really fascinating and necessary tension. The entire course pushes you to automate everything, to be maximally efficient, to use scripts to prevent human error.
Right.
Yet at the same time, it bans the ultimate automation tool, AI code generation, because deep human-level understanding and the ability to validate security are the absolute highest measures of success.
It raises a huge challenge for anyone in this field today. In a world pushing for maximum automation and speed, how do you balance that drive for productivity with the absolute non-negotiable need to understand and be able to explain every single configuration, every file permission, every line of code you write?
Especially when security, the entire point of the job, depends completely on that human oversight.
That is the critical thinking challenge this whole curriculum leaves you with.
It really is. It defines the difference between just being a tool operator and being a true master of the infrastructure.
A fantastic deep dive into what it takes. Thank you for walking us through this.